These problems are taken from the Barnett Trig book, 11th edition. And in this video, we're going to use the fundamental identities to simplify these expressions. And the method we're going to use for this is to rewrite any expression that we can in terms of sine and cosine, and then simplify it. So here is the first one. Sine of negative alpha times the secant of negative alpha. Sine is already, the sine of negative alpha is equal to, because it is an odd function, there is a trig identity that says the sine of negative x is equal to negative the sine of x. And another identity that we have is that the cosine of negative x is equal to cosine of x, and that's because cosine is an even function. So these are some fundamental identities we have. So we can rewrite the sine of negative alpha into negative the sine of alpha. That's what this is equivalent to. Let's see, secant, let's rewrite secant as 1 over the cosine of negative alpha. Okay, that's true. But we know that the cosine of a negative angle is just equal to the cosine of that angle because it's an even function. So this is the negative sine of alpha times 1 over just cosine of alpha because it's an even function. And then we can just multiply these together and get negative sine of alpha over the cosine of alpha. And this is equal to negative sine over cosine is equal to tangent of alpha, and we have simplified those expressions. All right, number 2, let's just rewrite everybody in terms of sines and cosines. So this is the cosine of u plus the sine of u, and the tangent is equal to the sine of u over the cosine of u. So this is equal to the cosine of u plus, and we can multiply these together. This will be the sine squared of u over the cosine of u. Let's continue to simplify this. This is a method that we can do. We can add these two values together by finding a common denominator of the cosine of u. That's what it needs to be. So we'll multiply this fraction times the cosine of u times the cosine of u to get a common denominator of the cosine of u. Cosine of u times the cosine of u is the cosine squared of u. This one already had a denominator of the cosine of u, so we just combine these numerators together. And there's a trig identity that says the sine squared of x plus the cosine squared of x is 1, or, because commutative is allowed, the cosine squared of x plus the sine squared of x is 1, and that applies to the angle u as well. So this is just a 1 over the cosine of u, and this can be written as the secant of u, because 1 over cosine is the secant of u. All right, the last one we're going to do, let's rewrite these all into sines and cosines. Cosecant of theta is equal to 1 over the sine of theta. Secant of theta is 1 over the cosine of theta, minus cosecant is 1 over the sine of theta, and this is times the cosine of theta over 1. Let's multiply these together. This is 1 over the sine of theta cosine theta minus the cosine of theta over the sine of theta. Now we're going to do in this one the same thing we did in number 2. We're going to get a common denominator of sine theta cosine theta. How do I do that? I have to multiply this fraction by the cosine of theta over the cosine of theta. The sine of theta cosine of theta. Now I can combine the numerators. This is a 1 minus cosine squared of theta. Now we have this identity I referred to earlier, which says that the sine squared of x plus the cosine squared of x is 1. If I manipulate this equation by subtracting both sides by the cosine, or by the cosine squared of x, I can get that the sine squared of x is 1 minus the cosine squared of x. So I see that 1 minus the cosine squared of x is really sine squared of x. That means I can rewrite my numerator in this equation, in this expression, into the sine squared of theta over the sine of theta cosine of theta. Now, everybody's being multiplied, and I can say one of these sines will cancel out with one of these. And this is going to be the sine over the cosine of theta, which is really the tangent of theta. And we simplified it down just to being the tangent of theta.